and we'll wait for like another minute or so to let everyone join. Maybe we should do a quick round of introduction because there are some new faces, which some of them I know, some I'm unaware of. So just the name and the title, that will be good enough. So maybe we can start. Marie, if you want to start.
Yeah, just my name and what I do at Rutgers.
Yes.
Yeah. Hey everyone, so I'm Marie. I'm an assistant professor in the Department of Psychiatry and core faculty at IFH.
Mamta, you're gonna go next. We are not able to hear.
You're on mute. Still on mute.
I'm sorry. Okay.
That's
Hi, I'm Mamta, and I work with State OBI Division as an Administrative Analyst 3. And we work on the STD measures and other ADAC reports.
Next, Michelle.
Hi, I'm Michelle Andrews. I'm an OBI also. I'm an administrative analyst as well.
Nate. I'm just following the order on my screen. So.
Hi, everyone. Nate Myers. I'm with Rutgers Center for State Health Policy, but deployed to Medicaid's OBI and work with some other folks here.
Awesome. Jonathan.
Hey, good afternoon, everyone. I'm Jonathan, and like Nate, I am also with the Center for State Health Policy and deployed to OBI.
Next, John Devolo.
Hi, I'm John Devolo. I'm the Director of Information Technology for the Institute for Health.
Ed.
Hi, I'm Ed. I'm data analyst at Center for State Health Policy.
Jake Lawrence.
Hi, Jake Lawrence, analyst here at EDMU.
You want me to put the thing on?
Jose.
Hi, everyone. Good afternoon. Jose Nova, Assistant Director for Data Management at the Rutgers Center for State Health Policy.
Felicia.
Hi, my name is Felicia Wu. I'm a administrative analyst at Business Intelligence. Thanks.
Charu.
Hi, everyone. This is Charu Verma. I am data core analyst.
Yiming.
Hi, everyone. I'm Yiming, and I'm a data analyst at IFH.
Joe.
Hi, Joe Vetrano. I'm over at Rutgers at Business Intelligence.
Hannah.
Hi, I'm Hannah Park. I'm a data analyst at IFH.
Neha.
Hi, I'm an administrative assistant at Office of Business Intelligence.
There is one name, WBL4. I'm not sure whose that computer name is.
Yeah, I'm Wayne Balfour.
Oh, thank you. Okay, thank you so much for the introduction. And we will start the session. John will be missing, the another John from IT. I'm missing the meeting, but we'll get into the session directly. We will revise very quickly what we did in the first session, and then we will jump into today's session, and we'll cover the topics for today. So let me share the screen. So again, the GitHub link, it's the same GitHub link. I did commit today's the notes. It has also the the queries that you can copy and use. So I will put that in the chat again.
Dinesh, sorry,
yes.
It says the recording is paused.
I didn't know. I don't know how, but.
Let's see. See if I do stop sharing. Let me record again.
Oh wait, hold on. It says it's recording now. Okay.
Okay, so I guess it's okay. So we'll start. I'm not sure on which computer that's happening, but we'll start the session.
And Dinesh, sorry, one more thing. It looks like some folks might be having trouble coming in. I just want to make sure if the folks at OBI are okay. You know, I know sometimes there were some issues previously, but okay. So Linda got in. So okay. So looks like we're good. So I think we can continue.
Okay, thank you, Jose. Sorry, it now says it is recording. Okay, so let's start. Everyone is able to hear me, right? No issues in terms of audio.
You are clear.
Okay, perfect. Let me share the screen. So I just pasted the same GitHub URL. It's public, so you will be able to access everything without even logging in. And if you want to clone this on your computer or on your GitHub account, feel free to clone it and put additional notes. You can clone, you can add your own notes to it. In that cloned repository can be served as your own repository. So in the first day session, we basically covered why relational databases. There are two types of, there are mainly two types of databases, like relational and non-relational. The relational ones are widely used. At IFH, we do use both relational and non-relational. Non-relational has a specific use case. So we'll not be covering that. So we'll be covering relational databases in this series. And then eventually, maybe if someone is interested in discussing non-relational databases, what are the use cases that we have at IFH, feel free to ask the question, or feel free to set up another meeting with me. I'll be happy to share the use cases for the non-relational databases. Again, we'll be using the editors. We will be using SQL Fiddle, but feel free to use the editor of your choice. These are online editors, so there is no need to set up the local environment. So we will save time on that. Again, there are basic terminology. The relational databases consist of rows and columns. Rows is called as record. You can also call it as a tuple, each row in the table. And table names are basically attributes. So you can call those as a column, which are the attributes of the table. Table and view structure will go in a bit. The naming convention, it's a very debatable topic. The last time we covered, a lot of people, the books that you refer for the databases, it says to use Pascal casing. But whereas if you look at the major frameworks, the programming frameworks, or even some databases by default, when you install database, there are some sample tables and database that it already has, which gets added automatically. You can choose to not to add those while doing the installation. If you look at the names which are used in the databases and the table are a little bit different. The one that you see in the books, it says like use Pascal case, but when you install and when you see the default databases and tables, you will see all lowercase and the words separated with underscore. So that's a majorly used convention by popular frameworks and even most of the enterprises. So, and then also singular form. So, you know, table, if you have user table, should I name it users or should I name it user only? Now, again, most popular convention, when you see the default ones are singular one. Even if your participant or user table has multiple users, but you still name the table in singular format. It's same that you might heard of when you do the git commit, although you already push the code, you don't say it in the past tense, you say it in the present tense. Just like when I committed the second commit today, I didn't say second, like, you know, the past tense as a commit, I said like commit in a present tense. So same, I would say use singular names, but also if you're using, suppose, data from from external vendors, right? So look at their naming convention, and if you want to add some additional tables in the same a schema, then use the naming convention, what is being followed by the vendor, the database that you're working with. We'll go into triggers, functions, and store procedure. Mainly, these things, I would say, you don't need to add triggers, functions, and store procedures if database is designed accurately. And these things only should be used when you don't have control on your database as much as you should have, and also when you don't own the application. Suppose there is a web application and it has a database. Now the application is doing something, but now you want to do some additional stuff behind the scene on the data. In that case, when you don't have control on the logic that is built using programming language for that web application, or even if it's a desktop application, then in that case, those are kind of a special cases when you need to use functions and store procedure on database side. Otherwise, avoid using or writing functions and store procedures in the database unless it's ultimately necessary. Because it's a kind of an exception. That means you will have to remember that you have a table, and when you add something to that table, there's something going to happen. So that's kind of use that you will have to remember always whenever you work with that table. And if you have another team member, and if you look at the table, he will see just the column names and rows, but behind the scene there's a trigger which is doing something else. So even it creates a communication gap. So if you're working in a team, that add additional complexity. So avoid using triggers, functions, and store procedure unless necessary. So these are from the previous, and then we also went into the day one, and day one also has again README file, and then also it has one data normalization README. So we will also quickly go through what the SQL basic the day one README file has. There are notes. I will say refer to these notes. These are the important tips and tricks. This usually, when you work with the databases long enough, you come across this standards that you should be using or implementing. So this, I would say, even if you go to the notes and refer only this section, like the tips and tricks, it has valuable information. Just like last time we covered why to use car and when to use car, and why to use varchar. So char is again fixed length. If I draw something, again, we'll just quickly go through it. Suppose this is your storage disk. You have I'm just drawing something, although it's not properly aligned, but it will cover the concept. Suppose I have char of length 10, means if I add my first name, or even suppose I add something like John name, so JOHN. So I'm filling out the 4 blocks, the address space into the disk. Now there are multiple type of disk. There is a rotating disk, which is hard drive. There is also other type of SSDs. There is a RAM, which uses different methodologies and the processes to store the data on the available space. So just simplifying a lot in terms of how it works behind the scene. So just consider we have char of length 10, and by default, every time I add name in, I can store in the disk, it will basically allocate that 10 space in the consecutive memory allocation. Now, why it is consecutive? There are different methods. It cannot. There are situations where it is consecutive, and there are situations where it can be random space into the memory. We will again that's machine level. I will cover a little bit, but if anyone has question, feel free to ask. So suppose for the first name, when I define char as a 10, basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it means till here, I allocated the space. So till here, from here to here, I allocated the memory space. But now when I'm adding a name, suppose in this case, John, I'm taking only 4 spaces, like 1, 2, 3, and 4. Means all of these memory blocks are being like filled up with a white space, right? So they're basically useless at this moment. It means we are wasting this much amount of memory when we are using char. When we use varchar, which is, if you look at this, there is a varchar, this data type. It is dynamic. So what happens is if you define varchar, even if you define varchar as a 10, it will, suppose the first time I entered John, it takes only 4 blocks. It will dynamically like organize itself to take only these 4 blocks so that it doesn't take any additional blocks that it doesn't need. So varchar is dynamics. It is able to adjust itself to only specific required size for the data that it is inputting into the disk or hard disk, or even if you're printing something on pen drive, if you're storing on the flash drives, it will use that also. You can have external databases storage in multiple spaces. So avoid char. The special cases to use char is basically zip code, phone number, where you know the length of the string. So phone number is 10-digit, but also at the same time, you have to think global. Now, if I just consider a phone number as a 10-digit, there might be chances when I go global, means if my application is being used by international users, they might add a country code. So when you design ERD diagram or the architecture for your database, so you have to always think global, including the character set. Suppose now I'm in United States, mostly I will start with, suppose, regular character set. There are multiple UTF-8, UTF-16, there's a GBK character set. So when you design the structure, start with a global thinking, even though your application may not be used outside the United States, but there is a chances now as a data analyst you might have come across, when you have to merge the data to some other data set, then again, having that common data type helps, because then you don't have to add additional formatting or casting to make it similar. So basically, char should be used. Zip code is a good example. Social security number is a good example. Phone number, unless I would say take 13 or 14 digits. If based on there are countries with a 3-digit country code also. So I would say take 15 to cover all of the use cases. So those are the special types where you should use char. Other than that, I would say avoid using char and use only varchar, because it can dynamically adjust the memory allocation. So that memory allocation happens behind the scene, where database engine itself deals with it. We don't have to pay attention to that as much, but knowing your data types always helps. Now, again, integer, int integer is used for storing whole numbers. Int and decimal maintains precision. So whenever you need precision in calculation, always use int and decimal. Avoid using float and double. The float and double are also the data types to store the number, to store the decimal number. But always use decimal. If you need decimal number system, then always use decimal data type instead of float or double, because it maintains precision. So we covered that part where the precision matters. But in scientific calculation, you need to have precision. For example, pi is like 3.14 and there are a lot of number, but sometimes now we made a standard to just consider 3.14 whenever we take the pi value. But there are situations where you need to have like all the numbers. The pi is very long, but maybe take another variable. So someone's maybe weight in lbs, right? So there might be precision you might need to keep all the values even after decimal. Consider currency. In currency, if you have a dollar amount, you will also need to store the cents. So anything after decimal, that's also valuable data. So in that case, you should be using decimal rather than float or double. Again, always use double quote. This is something to cover when you have a lot of string values, when you have a paragraph, something, and if that paragraph going to have a quote said by someone so, or if you have a paragraph putting, suppose if you're storing medical information, medical history of someone's, and then if doctor is typing the paragraph with a history of medical history, then he suppose by chance used a quotation to highlight important word. So whenever you start, suppose you get the data, then I would say make everything which has double quote within the sentence to single quote, and use the prefix and postfix, which is the starting and end, as a double quote, which will save you a lot of hassle in terms of when you do additional data processing on that data. Then there are timestamps. So I would say you can store date time combination, or even Unix timestamp as a string, but always use data type specific to each of type, right? So there is date, there is a time, there is a date time, and there is a Unix timestamp. So always use a specific data type, because the database engines are optimized to deal with the data when it is defined properly. Because if you don't define the data type for a specific, suppose specific today's date, if I don't define the data type, the database will store it as a string, and whenever it's doing comparison, then it will have to typecast it internally. So it's an additional process. Suppose you are comparing date to date, then database, because in the database I stored as a string, then database will have to do additional process, which is casting, to cast it to the proper data type before comparison. So when it's a one record, it's not overhead. When you have a lot of data, it's a huge overhead, because then it has to go through each data point to cast it. So it becomes overhead when you have millions and millions and billions of records. So those are the important points. It's already here. You can quickly take a look whenever you want to refer to these notes. So there is a database normalization. This we will cover when we go in detail while writing queries. But the database normalization, suppose I have a database structure. For example, even if we take here, let's go to, so here, if I take this, let's open this go a little first. Okay, so this table, or even if we just look at this here, to come to this stage, these are the backticks. You can remove the backticks and just use without backticks also. Backticks are basically used for string interpolation. And also basically most of the editors nowadays are even IDEs. Backticks helps to identify and highlight those are as variables, attributes, keywords, and all that. But when you're
what
writing,
is the word you're saying?
Backtick. So the backtick is right below the escape button. So on your keyboard, there is this escape button on the left top side corner, and right below the escape button, there is a backtick button. Backtick. So we don't really need backtick. You can even run without having backticks, which is completely fine. For defining column names, you cannot use double quote, or you cannot even use single quote. It's a no-no. There are a few now database engines which accepts it, but in general scenario, like majority of relational database engines will not accept column names enclosed in either single quote or double quote. either it can be enclosed within backtick or just as the plain variable name. So by looking at this table, there are other tables also here. For example, even if here, or this table, right now you can, these are the examples, I did keep some variations for you to try and play around. There you will see there are a little bit of variations and the way it is defined to cover what things you can do and what not. So when we have this table, to come to this table architecture or even the fields, it's been through some decision-making process. And that decision-making process is usually called as normalization. So if I go back, normalization's main purpose is to reduce data redundancy, basically eliminate data redundancy, data anomalies. There are there is a delete, update, add anomalies, which we'll cover up later, and data inconsistency. So whenever, if you haven't designed yourself and if you received a database table structure from somewhere else, you will see the way it is defined, it's basically been through some decision-making process that usually a database normalization process. It's a definition we usually don't think when you're creating the architecture, but it happens by default because you've been doing it for so long. But the main purpose of database normalization is to eliminate data redundancy, eliminate data anomalies, and data inconsistency. We'll go through that in few. And then any changes that require changes in the table structure. Suppose we are adding a row, in the first column, I added my information. Now in second column, suppose I'm adding whose information. And to add that second person's information, if I need to do changes in the table structure, that means my table is inconsistent. It's wrong. It's not architected properly. So it means you need to normalize it. So that's kind of, if you're a beginner, you will be coming to that situation. Oh, so I have, suppose in this scenario, I have first name, last name, and suppose here itself, if I add my employment information, suppose I define here my employment, right? So if I'm defining my employment here, now if I'm doing my employment information here, then my employer name, my employer address, right? So if I put all this information in this table itself, this table is not normalized because this is so hard coded here. It will have a lot of redundant data. That means suppose if I'm adding employment information for myself, means for every row that I am recording here, I will have to add the similar type of information. Just consider here the example, we all work at IFH. Now, if I keep the employment information in this same table as the user table, means I will have to add that IFH information redundantly to each row, which is redundancy. You can avoid that redundancy, create a different table for employment, which contains the employer details like employer name, address, phone number, contact information, other stuff. And then you can add a foreign key to build the relationship between the two tables. So I don't have to repeat, and there can be multiple employer. And then I can just choose the key associated to the employer when I add the user. So I don't have to repeat that employer name, address, contact information again in the same table. If you look at that, you are adding, even if I add that 4 columns for the employer, that 4 columns, if you repeat multiple times, that many times you're repeating that 4 fields. If that, suppose first field is defined varchar 100, second field is varchar 100, third field is varchar, that varchar 300, you're wasting each time for small set of records, it's okay. But if you have like millions of records, then that's the issue. Means that much amount of memory, it's being wasted. So the normalization process, again, if you're changing any changes that requires changes in the table structure, means you have to revisit your table structure and do the normalization again. Now, when you have normalized data or database tables, normalized tables, now you have basically you have user, which is participant or user, then you have employer, and suppose you have some other table, say the job titles, right? So which contains only information about the title, the minimum and max range of the salary, and other information. So you have 3 tables. In first case, if you add all 3 table information in one table, then when you fetch the data, you don't need to do the join. But now you have 3 tables because you normalized to improve the, to reduce data redundancy, to improve the performance. But now when you have to fetch the information for a specific user, you will have to do the join in all 3 tables to fetch all the relevant information. So that's the only, it's not still a side effect, but it is like you have to use joins when you do the normalization. There are very popular ones are first normal form, second normal form, and third normal form. There are additional normal forms, but if your data is normalized till third normal form, then it is sufficient enough to build your application, do the other database procedures and process. So, and then anomalies will go into bit with the example, but this page basically covers normalization. Therefore, some examples added. This will also go in detail when we write the query in a few minutes. But feel free to refer this page. It has first all 3 normal forms covered. To give the highlight, what the first normal form is, basically, you remove basically redundant data. You design in a way that reduces the anomalies and data inconsistency. So the first normal form basically covers there shouldn't be redundant data and there shouldn't be multi-value data. Maybe let me just do one example from here. So here, so in day 2, there are a lot of queries been added here. So you can run this either in SQL Fiddle, but in this scenario, maybe what I will do is I will run in the local database. So let's see. So again, I already ran some tests before pushing the data to the Git repository. So I'm going to just drop the database and I will create the database again. So if you noticed here, we are basically doing data definition commands, which is basically create database, create table, and alter tables. The alter also comes under data manipulation, but if you're adding primary key and other that, it can be considered as a part of definition. So here I could have done drop database, IFH database series, but I did this thing. The purpose of doing this, if exists, is basically it's a fail-safe option, right? So it will delete if it exists. And it will stop that executing that command if it doesn't exist. So in this case, if I run it again, you will see there is a yellow exclamation mark. This database doesn't exist. So it's basically stopped there. Now, if I now suppose if I create this database, and now I created this database. You can see this database here. And if I run this now without this, so it ran first time because it existed before, it was there. Now, if I run this again, now it doesn't exist, you will see a red cross mark. So writing queries that way, it helps. If you see, like sometimes if you're using some application and it crashed, so that application is crashed because the error wasn't handled properly. So in this case, this is an error. right? Because that database doesn't exist. And I didn't handle it properly. So that's why I'm getting red cross mark. Whereas if I do again this, like this, you will see exclamation mark, means like, you can consider this as a application crashing and application not crashing. So here application didn't crash because I handled it in a fail-safe way. So these are some of the benefits, and this is a best practice to always use a fail-safe way of writing query. Now you are using your own database, and if you designed a web application and you have your database being accessed by a web application, if your database is rendering that red cross here that you see, that means your web application is going to crash if some error happens on the user screen. And it's a very bad experience. So to avoid that, there is in programming, there is an exception handling. The way that you handle the errors and the exception. For example, divide by 0 is one of the best example. If you don't handle it, and if application comes to that situation where it's executing that, then it will just crash. You can call it as a blue screen. Back old days when you used to use Windows computer, suddenly you used to see blue screen, right? So that blue screen is basically, again, a good example of something wasn't handled properly. So instead of giving at least the user information that something went wrong, it just crashed to the blue screen. Now you cannot do anything. So you just have to turn off the computer and start again. So these are some of the best practices. So I would say always follow this. And I did cover in the notes section what to use when and why. So you will see, again, when I'm writing query, there are multiple variations of the way I wrote the query. But whenever you refer notes, you will get to know what to use when. Maybe at the end of a series, I will just remove the test things that I have already did here, and then only keep the things which users should be doing. But that I will do at the end of the series. But right now, for the practice purpose, for the references, I'm going to keep this all things here. Now, here, I was about to explain the data analysis. Let's see. If you guys want to practice and run at the same time on your end and have some questions, feel free to ask. In the SQL Fiddle, you can choose MySQL here. You can also do other types if you want to practice at the same time. But right now, these are specifically covering the SQL structure, which is like more towards the MySQL. But also it has general purpose queries. So now these two tables, let me create this table. So again, I will create the database because it doesn't exist. And this, so we have this database now. I'm going to create this two table. Okay. Okay, so these two database tables are created. If I refresh, I will see these two tables here. It's a kinship table and there's a participant table. Now, here, again, as I said, you can create table without this backtick. You can just have plain straightforward variable names. For example, if I take this and create another participant two table. And here, again, here I said default null. These are again something to notice. I'm saying create table, the table name, and then I'm defining the column names and the data type, and then the constraint. So there are multiple constraints: the primary key, foreign key, not null, and unique. So in this scenario, I'm using unsigned. Again, unsigned is so okay. So to cover unsigned, I will just draw it. Yeah. So this is suppose our number series, right? Here 0, all the positive numbers will go this way, all the negative numbers go this way. So if I say unsigned, means it will ignore completely this part, right? So that means if suppose something is from 0 to 255, which is basically 256. So if I did unsigned, I'm able to use all 0 to 255 number in that space. But if I say signed, means it will also use negative number, means this 255 will be divided into like half, right? So it's if you don't really need signed number, then you always should use unsigned number, because then you get more address space, like you get larger length. Whenever you do sign in terms of digits number, means you are dividing your current number range into half, because half of the length went to the negative numbers and the half went to the positive number. So I would prefer, there are very rare cases you will have your primary key as unsigned. I haven't seen any use case. So it should be always unsigned, which is here, which is what it is saying unsigned. And there's a not null auto increment. So auto increment is, I can remove this and I can manually handle the primary key increment, but it is not best way of doing it. Because if you have an application, then you will have to keep track of the records that you're adding to the system and increment the primary key manually. So again, when you define a primary key, most of the database engine by default, they create index behind the scene. So even if you don't define it, majority of database engines, they create indexes by default when you just say, when you say primary key, and even when you don't say primary key. There are some database engines, they don't even create any index behind the scene, so they will just keep it as it is. Also, it depends on, there is a config file, means all this database, there are certain things is default in the config file. Those certain defaults defined in the config file, whereas I define the character set, means anytime when I create the database, I don't have to define character. Suppose I'm typing as a character set UTF-8. I don't have to define this, because in my config file, I have already set that to use as a default. So even if you run this, you can define character set at row level, column level, which basically in turn, whenever you add a record, it will go row level. And also you can define character set table level and also database level. Why different character sets, different language has specific requirement. We at IFH have a multilingual survey platform when we manage multiple languages, including Urdu, Cantonese, Mandarin, Korean, Pidgin. So this character set does matter, the character set that you choose, but most likely you don't come across, you have to pay attention to the details when you are designing something. One of the thing we noticed in RedCap, there are certain Spanish and other language also, there are special characters that RedCap doesn't take. It basically crashes when you enter that special characters, because it is using a certain type of character set which is unable to handle those special characters. But whereas in our side, we have UTF-16 and GBK combination, which handles all of the characters. Even if you enter anything for that specific language, even the special symbols that you don't usually see, it will accept that and store in database. So in here, the table I'm creating, yes, I can define character set or I can skip it. Let's just skip it, for example, if I'm running it now. And then I define this as a default null. Now, do I need to say null? Even if I suppose remove this, right now maybe this has a default value as a false, but suppose I remove default null, it is completely acceptable. You can do null, and by default database engine will consider as a default value. So let maybe run this and let's see, we are creating the second table right now. table definition, let's see. For now, auto increment, that's what it says. So, okay, so we can define this as a primary key. I can do the So I just created this table because I defined auto increment. That's why I had to define primary key because auto increment is in relationship with the primary key. When you have primary key, only then you can have something auto incremented. So I just now created this table. If I look at this table structure, you will see, although I didn't say in this definition default null, I didn't say this, right? But then still, you can see the default expression for this row is null. So there are like multiple ways of defining it. You can skip this default and whatever you define here, it will consider as a default. Also character set, now I define the character set. So behind the scene, it has that character set, although on the global level, I already defined the UTF character set. So I also don't need to define this. But even if you define it, suppose you're working with someone and they already defined global character set, which is different than what you want to use, then only then you should be defining your character set depending on the use case. But otherwise, if your global definition of character set is something set which you want to use, then you don't have to define the character set specifically to individual column or database or the table. Now here we have two tables. So here in this table, if you see, I wrote this table creation definition without backtick, and which is absolutely fine. You can run this without backtick also. So there are these are the kind of variations I kept there just to have the idea. And also, if you see here, I defined the primary key right here, or also I can define primary key something like at the below, because this primary key I can just add constraint. So this is basically I'm defining the constraint and saying this column name is a primary key. This column name is a foreign key, and this references to the table which is here. In terms of primary key, I can just do like this. I don't have to specifically go add that constraint separately. It can be covered like this also. So we covered few points here. Again, each of the data type is chosen for a specific purpose. You know, if you have something first name, you shouldn't be doing 500. By default, when you don't define it, based on database engines that you're using, it might just say default to 255 or 191. So defining yourself is always a good idea, although it's a dynamic, but also when you export it, the database architecture and give it to someone, then sometimes it's an issue because if that has a certain length specified to the whole database engine, then it might not accept it. So I know the first name might not exceed more than 50 character length. Then I will always define myself. Okay, this is 50, this is 50, and all that. So I did mention that varchar is dynamic, but being a dynamic, there is overhead. You know, to add that dynamic behavior, it has to like keep track of certain things. So this is additional bits that it takes into the inside the memory to keep that dynamic behavior, but it's a very less overhead than using char. Also, I wrote these keywords in capital letter. You don't have to write this capital letter. I just wrote this to give the distinction between the regular the names which is defined by user and then the one which is the default keywords, like the keywords which is being part of SQL language itself. But it does not necessarily need to be capital. You can write small letter, just like what I did here in the Boolean. You can write everything in small case. It's completely fine. Also, I defined false here. So this is something interesting. So every time when I enter the information in this table, by default, it will have false. If I don't mention it, right? Suppose when I'm submitting form, if I don't mention it, maybe for example, we can go to our survey system. Maybe not survey system. Give me a second. Let's see this here. Let's go to the mock survey system. So this is our test website. So maybe I'll just show you example. If something's set as default and when something that haven't been set as a default. Right now here, let me see if that one exists. Test, okay. So I'm going to add test one user and I don't add last name, right? So I'm skipping every other field. I'm just putting the data in first field. I skip literally every other field. I haven't chose any value in other field. Now I'm going to submit this form. So if you see it accepted that, and it was able to enter the value in database. So now suppose I try to find this, I will see it exists, right? The one that we just added, it was able to accept it. Now behind the scene, if I go to, let's see. This is live application. I'm messing it around because it's just our for test, so it should be okay. Now in here, there is a participant table. If I look at this participant table, for the last name, by default, it's null. Suppose I make it as a not null, right? So means I will have to enter something, otherwise database will not accept it. Now, if I apply, by the way, this is like, let's see, okay. I guess there's already value. Now I'm trying to apply this not null globally, and if there is already data in the table which has null values, that will create issue. Let me see if I do to the other name. Close it. I should delete this actually, because this already has null. So what we should do is let's remove this. This test one already has null record, and if I'm applying not null constraint, it is going to apply to the whole table, which is sort of false because this record already exists with a null value. Now I just deleted that. Let's see. So let's close this again. This and the last name. I'm making it not null. Let's see if it goes to. Okay, so it went through. So what I did right now, globally to this table, I said this column need data in it to save and commit the transaction. Whenever it begins the transaction, before it was able to accept the null value, but now it will not accept the null value. Means this field will always need some data in it to make that transaction complete or complete the transaction. I close this. Now here I'm going to add, I will add the same record because we already deleted that. Now if I click save here, so it's not going through. I'm clicking here, but let's see. So now if I look to the console, so every time I'm hitting submit, it producing error, right? So see, it's failing that post request. So the request it is sending to the server, it's failing. First, it is talking to the application, and application is talking to database. Database said, no, I cannot enter this. Database returned that status to the application, and now application is returning that status to the user. Right now, I didn't expose to the user, suppose, but because this something we didn't want to design. We are just doing this for test. So if I click here, I will try to find out the reason. So if you see the error that is produced, it is failing the integrity constraint. So it failed that integrity constraint because I'm saying that last name needs a value. And unless I add value to that last name, it will not save that record to the database. So database doing its job very well. It was able to detect it. It was able to convey that status to the application, and application was able to act accordingly, whatever database is asking. So if you see, it's clearly saying that column last name cannot be null because we said it as not null. Now, if I say last name and save this record, sorry, this Zoom thing is coming up to the bottom side. Now it's saved. So now we actually fulfilled that requirement by adding data into it. So those are the benefits that you get. Now, if I had the use case where I wanted to display the error to the user, I could have showed them error message, but in this application, I didn't define it because we weren't planning to have that structure. So I can like gracefully show the error message to the user, hey, last name is required. So you will have to put value into the last name to submit the record. So those are the benefits. All this constraint, why we use it, why we have it, because every constraint has a utility to it. They have a good utility. If you consider, even when you use Facebook, Twitter, or any other data-heavy application, behind the scene, it's just the database. Whether it's a relational or non-relational database, but everything, the user interface that you have is a different thing. But technically, the core of the whole application is database. If you don't have the database, you basically lack. It's basically kind of saying Web 1 technology where you just have static pages defined without having backend system and database, storing the large sheer volume of data, allowing users to input the data and all that. So having a good database design, it's very useful in terms of your customer experience, user experience, and also later when you do data analysis and data processing, these all things matter. Suppose by default, I'm entering that mock participant value as a false, means when I export the data, I will have that 0 value for that column, right? If I haven't defined anything, so that means that column will be always empty. So if I have to do some data analysis, either I will have to manually then ingest that 0 to do the further analysis, but now I'm handling it while the database is in live state. So it also reduces the future work if you have properly designed database. Now, here we'll go back. There are a few queries here. The create database, then also the constraint foreign key, parameter key, not null, unique, and all that. We will go back to the. Sorry, I had to go back and forth because giving the picture is also important, and it's kind of like very interlocked system. Means everything is dependent on something. If you don't see it, you will not be able to catch the information. So database normalization in the day one, it has things which we are again come back to revisit. If I just go to the day 2 now, here, this is basically just the introduction. Again, this is a markdown language. Behind the scene, it's basically look like this. But you can just copy it without going into the markdown language detail, and that should be still okay. So if we go back. Now, it's just a description. Again, there's a description of the keys. The keys are very important. When you are a database administrator or DBA or data analyst, and if you want to heavily use database, there needs to be justification why I want to use database, right? So if you don't have indexes on your database tables, using database doesn't even make sense. So having a flat file and having database without indexes is basically same thing. So you don't, except 1 or 2 additional things, maybe you can manage the duplicates, remove the duplicates while putting database. But if you have a database table without indexes and you have a flat file, it's basically the same thing if you don't have indexes on table. The runtime running something on the flat file and the runtime running something on the database without indexes will be almost same because it is not improved or it has not been designed the way it should be. So you get the benefit of database only when you follow the data type definition properly. Then when you have indexes, so there are multiple indexes, cluster and non-cluster, but you don't have to pay attention to that in integrity. When you define primary key, by default, it creates the index behind the scene. So for each table, now here there's a description for the primary key. I've been talking about this, but if you have a question, if I missed anything, please let me know. Do you guys have any question till now? Any questions, anyone?
Hey Ganesh, I have a quick question about
Yes.
How did you link ADHI website to the SQL database?
All right, that's a good question. So linking is, okay, so maybe if I want to define the linking, let's say here, let's go back to the drawing board. So this is application. This is application. Suppose this is application. This is database, right? Then there is a connector in between these two. Now, depending on how you are designing your application, this connector will change, or the design of this connector will vary. Now, I have this ORM. Sorry, I'm just using the trackpad, which is object relational mapping. Means every object will have relational mapping. This is kind of a translator, right? So you have a participant, which is this participant info screen. This is object, because this whole information you're looking at, you consider it as an object. Now there's a object-oriented programming. Now object and class. A class is basically something. A person is a class, right? So our human is a class, but then male, female, you can, even in male, female, you have me as a Dinesh, Hannah, Marie, Jose. These are individual entities, means they are objects. So if you consider male as a class, then means Jose, me, will be the object of that class. So that's basically object-oriented programming in a nutshell. And if you say female, then if I create object like Murray, Charu, so this will be the objects of that class. So similarly, now consider this when I'm adding some users. Suppose I'm saying Dinesh, I'm creating an object. Now that object gets this ORM, object relational mapping, basically translates that object to the database query, right, in terms of the row. So this object relational mapping is very important, but also you may not have this ORM depending on the programming language and the framework you're using. Right now, my application follows the object-oriented concept. So it has ORM in between, which basically any object entity I'm entering from the web form, this ORM has a job of converting that to the row and pushing to the database. So this is basically connector. And this connector, there are frameworks, there are ready-made frameworks. There are in Python, Java, PHP. In Java, Hibernate is a very famous framework. In PHP, it's called Eloquent. It's a very famous framework, which is ORM framework. So you don't have to do like, it's kind of like, it provides you high-level abstraction. It makes your job easier. So you don't have to like worry about every low-level details, how this will be transcompiled to something, right? When it is converting that, how it will be converted. You don't have to worry about that, the very low-level details, because this ORM frameworks provide that abstraction. So in Java, there's Hibernate. In PHP, there's Eloquent. In Node, Node has, I guess, Sequelize. Sequelize is a ORM framework in Node, which is very popular one. So those frameworks take care of that. So this is basically connector in between, sitting between these two to add this conversion and mapping this to the database table row and storing the database. Now, if you want to see the detail, let's see if I can. Let's see. So if you see, now this is running in local. Now there are, to this ORM, right? I have some connection parameters that I define. Now database connection, host, now that database is running. The one that this live application is talking to is running in the remote server. But when I use something locally to run this application, for the local application, that database is running on my local machine, which is this host. This is a port to talk to that database. Now this is a table name. This is username and password. This is sitting on my local machine. So it doesn't matter what I keep username and password. When you are putting in the production, make sure you have strong username and password and other details. So this is for local host. 127.0.01 means your local machine, means the laptop that I'm using. If I put IP address here, means it's a remote server. But right now, as I said, I can write even local host. It will be the same as saying 127.0.0.1. This thing and this thing is one and same thing. It's basically same. I can replace this with this and it will still work fine. So maybe let's say if I take this, I will just show you one application running. So let's say this is start. And so what I'm doing right now, I'm running this application locally, means on this server, on this port. I'm running this application locally. This is my front end. This is my back end. And then back end basically talks to database. The thing you see here, where were we? Oops, here. So the thing you see here, I'm tailing my application, which is my backend logic, use this detail to talk to the database, this database. So do you see, so when I come here, there's a local host. So if I say, clicked on it, okay, we'll go back, edit connection. So if you see this database is localhost, right? This is localhost, means running on my local computer. So this database is what my my application is going to use. So right now, suppose I go back here, that's what the parameter I define. So I'm telling my backend application logic to use the database running on this computer to use as their database. And I just started my application here. So you'll see, let me see. So this is, if you see this running, application is running on my local computer right now. So this is localhost. This is not IP address. It doesn't say redgers.edu something or like that, right? So this is localhost. It's running on my local computer. Now, if I log in, let's see, what's the password? I don't remember the local password that I set for it. Let's see. I don't remember the local password because I might have set it to the production. Let's see. And I don't really remember the password anymore. So, but anyway, so this application, which is running on the local host, is talking to the database using this configuration I defined, right? So this is the configuration which is helping this code, the backend code, to connect to this database running on my local computer. So this is the database running on the local computer, and it is using that to connect. In terms of when you have a server, everything will be running on server. This will be some IP address or the domain name. It might say rutgers.edu, ifh.rutgers.edu, and the port number for that server, and it will be talking to that remote server. And then also this parameter will change to specific IP address of the database. Is that does that cover your question?
Yep, thank you so much.
Yeah. So it really. Sorry, go ahead.
Oh, sorry. I was just gonna ask if the ORM, does it work one way? Like I know that it will fetch data from the websites like ADHI and then updates the database. But is it possible that it works two ways, in a way that if you make an update on the database, it also updates the website that you're linked to?
Yeah, it works both ways. So whatever you see here, maybe for example, this Abby record. So if I go to this person, so this person now, oops, okay. So participant ID of this person, I'm going to copy this. Abby, now the person is Abby here for this participant ID. Now, if I go to, so the database is that one that we looked at is the server with this IP address. Now, if I go, I will have to go to that, which is this server. If you see the connection parameter for this server will be different. This is talking to that server with this different details, login details to that server. Now, in this, say, so I'm going to choose that participant record. See, that participant ID was this, right? Abby, right? Now, if I say Abby1, or let me say Abby test. I'm saving this record. If you see, I'm making changes directly inside the database. Now, I made the change there. Let me refresh this page. You can see here, right? It's a Abby test, right? So the changes you did in database is reflecting here. So even, and then if I open this record again, if I update this and save it, right? So now it's saved as Abby. Now, if I go back to this and then reload the record, it will say Abby. So it's a ORM. It's a definitely bidirectional. It has to be bidirectional because it when you update something means you're pushing. When you are reading record means you're pulling. So you can say when you save update, it pushes the data to the database. When you read, it pulls the data from the database. So it has to be bidirectional, and that ORM act as a intermediator. Even when it coming from database, it will convert back to the object and give it the application. When it is going from application to the database, it will convert that object to the table row, right? You know, the row that we add to the database. So this is like row to object, object to the row. So it does bidirectional conversion when you use the ORM. Do we need to use ORM? You can actually write your own ORM, whereas I myself did for the previous application. But now the big companies, even the open source community, they provide their own ORMs. You know, the framework. Suppose in Java, you use a very famous framework, Hibernate and Struts, Spring and Struts framework. The Spring framework uses Hibernate. So now the companies themselves says, hey, you don't have to define everything yourself. You just write your own code, the business logic that you want to deal with, and you can use this ORM to manage that low-level details of conversion. So that's the benefit of ORM. you can if you want later, maybe I can show you even how to write just your own basic ORM. And it's definitely possible. You can write your own interpreter in between, sitting in between, who basically do the job of transcompiling. So any questions?
Thank you.
You're welcome. Now, so we were talking about the table. So this is database table, and this table has these are the record, one record, second record, third record. Now, this records have some unique identifier. Just like when I'm using this participant table, each table has ID associated with it, and there are different participant ID, family ID, which is a separate matter. So same way, I define this to use this column as a primary key, right? But there are multiple types of keys, not only primary key or not only foreign key. There are multiple types of keys. So there are definitions here, which is like also explain the keys. Also, again, here is the Pascal case. You can use lowercase based on the type, the things that you have in your database that you're working with. So you feel free to choose the casing format as you need. So super key is an attribute or set of attributes that can be used to identify a row of a data in a table, or is a super key. So attribute or set of attributes, right? So this is one attribute, second attribute, third attribute. When I say set, means it can contain one or more attributes. It can be two, it can be one, it can be two, it can be three, it can be four, it can be five, it can be six. So that's a set of attribute, one or more thing, a set. Set is also data type, data structure. So super key can be one or more attributes that we can use to identify the record. So here I can use SID to identify this record. I can also use this registration ID to identify each individual record uniquely. I don't have, there is no duplicate here, so I can use this to identify that record. Also, email are unique, right? So I can use email to identify this individual record in database. So, and then also I can make a combination of this two to identify this complete row in a database. I can use this combination of two to identify this record. So super key can be one or more attributes that uniquely identify each row. Means when you have data in database table, if you are not able to uniquely identify your each row, right now when I called participant with this ID, I was uniquely identify that specific participant with this ID, right? That's a unique identification. It didn't pull like 10 other records with this. It just pulled one because that's how it is mapped. So that means it has to, each row in the relational database has to be, there should be a way of uniquely identifying. If you are not able to uniquely identify each record, means your database is not useful at all. You have inconsistency in database, it will be very slow. It is better not to use database in that case if your records are not uniquely identifiable. So that's a super key, one or more set of attributes which uniquely identify the table is called super key. Now, candidate key is a minimal set of super key. It's a minimal set of super key which can identify a record. Now, suppose if I consider this as a super key, but if I take only SID, I'm able to still uniquely identify each record with that SID, right? So it means this is a candidate key. If I take this, in this I have three attributes, but if I take the two attributes, I'm still able to uniquely identify each record with these two attributes. Now, in this subset, I can even take one, and I'm still able to identify. So the minimum, basically, it's a minimal set of super key. Whatever that minimal set is, they are called as candidate key. So if you cannot call this candidate key because I can use email, I can use registration ID, I can use SID to identify each record uniquely. I cannot also say that this is a candidate key It basically fails for that condition, which says it has like this and this. If I use independently, they can still able to identify record uniquely. So this will not be candidate key. This independently will be candidate key because each of them are able to identify the records independently. Feel free to ask the question. Sometimes they're like a simple definition, but they're sometimes confusing. So feel free to ask question. Now, primary key. I have this SID registration ID email. I can technically even use first name, even use last name to set it as a primary key if they're unique. Suppose if I choose this SID as a primary key, so the other keys which I didn't choose, although they were able to uniquely identify record, becomes the alternate key. And then the one that I chose is primary key, right? So these all candidate keys are able to uniquely identify the record in the table, but I'm choosing one key as my primary key, and I'm choosing that and telling database to use that to build the index and create the primary key. So once I choose this, the other keys which can uniquely identify the row becomes the alternate key. A foreign key is basically the one that I just showed a few minutes before. Here in this table, let me drop this. I dropped this to table. Created this to table. And there are some records you can use to insert values. Now this two table, participant and kinship. So the select star star means everything. I'm not specifying individual row to pick. So here the kinship ID, right? This kinship ID belongs to this kinship table. So there is a second table, which is kinship table. So this is table, this is table, this is table. Let's ignore participant 2 for now. So in kinship table, there are entries related to the kinship. And then in the participant table, I'm referring that kinship. So this is foreign key because this key is a primary key in that kinship table. And that's basically primary key. So foreign key is basically used to build the relationship between the two tables. Also, a part of normalization, each table should describe one entity. So you break down the tables into individual entity, describing individual entity, and then you build the relationship using the foreign key. And that foreign key is important. If you don't have a foreign key, and if you do the join, it will be very slow, right? It will get confused. Your database will crash, basically. So, so that's the foreign key. Now let's go to the surrogate key and compound key. Compound key is basic composite key. If you combine any key with more than one attribute is called composite key. If you like combine this, these are basically composite key. Surrogate key, when there is no natural primary key. Suppose in the table, if I have data and then none of the column satisfies the uniqueness condition to find the record in the database table, then I will manually add a key, because none of the columns are able to satisfy that uniqueness condition that needs to define a primary key. Then I basically myself will additionally define a key, which basically called as surrogate key. Compound key is basically, if composite key has at least one attribute which is foreign key, then it is called compound key. Compound key, you don't need to worry about this. All other things are highly important. The primary key is the foremost and the foreign key is the foremost. You need to have foreign key, and if you have the entity breakdowns into unique tables, then you need to have foreign key to build a relationship. If you don't have these two things, using flat file and using database is the same thing. So if you want to build a table, if you want to build database, you need to make a use of the indexes. Indexes behind the scene are B tree. There are structures. B tree is optimized for accessing the data on the hard drive fast. There is a binary search tree, there's a B tree. We will go into the details in a few, but B tree is a structure which is majority of the databases uses to build their indexes. Here in the notes, I covered those points. Indexes commonly queried fields. Also, when you query the database, you mostly will query using the indexes because that will help you to retrieve the data fast. And that's what the primary use of indexes are. You want to query something, you need to have indexes for the fast retrieve. You will see the differences. I notice it very often when I work with external databases, when I have applications talking to each other. If they don't have proper built indexes, you will see the runtime of the query varies. So it's very important to have the proper indexes as well. Now, as I said, there is a B tree structure which is commonly used to build indexes. There are other ones, but majority, I would say 95% of databases uses B tree structure. Because database data gets stored onto the hard drive. When you write programming, when I write application logic, that mostly majority gets executes into the RAM, which is your random access memory, temporary memory, and the CPU registers. But when you work with databases, everything gets stored into the hard drive, and B tree is optimized to work with hard drives. Right? Whether it doesn't matter what type of hard drive it is, whether it's SSD, it doesn't matter what type it is, but to work with the one which is like persistent storage. So that's a persistent storage. RAM is a temporary storage. RAM gets wiped when you restart the computer or when you reset it. So when you use persistent storage, disk drives, then B tree is the data structure. Go to data structure to store data optimized way. Also, B tree has, this is a logarithmic time complexity. Every query, every logic has either time complexity or space complexity. Time complexity is how much time it takes. Space complexity is how much storage space it takes on the storage. So for tree, it is a log big O. This is called as a big O of log n. Means in linear, if you have more records, that the runtime will increase, but in log that will not be the case. It will be very consistent because it will in binary search tree. If that's something, binary search tree is something you can quickly grasp. Let's see. So this is root node. This is child nodes. And these are like another 2 nodes. So if I write down 10 here, so binary search tree, like left node always has smaller values. So it may be 7, right? And the right node needs to have value more than what is value in the root node. So it can be 11 or more than 10, whatever it is. So that's the binary search tree. And then if I put here 5, maybe I can put 8 here. So in this binary search tree, if you have to find 7, right? So if it is linear, suppose I'm putting this as 5, 8, 7. So this is linear. This track. Okay, let's see. I don't know if it's readable, but 7, 10, 11. So this is linear right now, right? So if I have to find 7, I will have to go to this, and then I will find 7, right? So any number I have to find in the linear structure, I will have to like go sequentially in a serial manner. When it is like a binary search tree, the algorithm runs in a way that it divides, it's like a divide and conquer. Whatever the root is, now 7 is smaller than that, so it will directly jump to the 7. So it doesn't have to like look into the right subtree. So it's kind of reducing the amount of element it has to scan to find some element. So every time you go one level deep, the data gets divided into half, which basically saves your half of the time, which it could have taken if it was in a serial manner. And the same way B tree works, but in B tree, the thing is all the leaps needs to be in the same level. Here you can see the leaves are in the 3rd degree. Here it's in the second one. In B tree, this will fail as a B tree because every leaf needs to have to be in the same level. But anyway, so this is the benefits of this data structures are huge. And that's what it means when you create a primary key, because it uses the structure to scan and navigate. Whenever you do read write operation, it basically goes through this. We are running out of time, actually. I'm sorry for that. So we'll just quickly go through this. So the runtime, which is a time complexity of running a query, it's a log or log n for the B tree, big O of log n. The space complexity, we will go into that detail later. Then user must reevaluate queries that takes more than 500 milliseconds. This is specifically for the web applications. I know when you have the other data sets, it will take more than 500 milliseconds. But for web applications, if something is taking more than 500 milliseconds, that means there is a scope of optimizing your queries. There's a scope that you should optimize your queries of the tables, restructure the database, and all that. Primary key and foreign key and unique constraint create the indexes by default. Whenever you define this, it will create the index by default. Primary key provides the fastest lookup, equality first and the range next. So that's basically how the B tree structure is. And again, primary key cannot have null values. If it doesn't accept null values. If you define something as a primary key, it will not accept null values. Foreign key can have null values, it's okay. And any other column can have null values based on what constraint it is defined. If the constraint is not null, then it will not accept not null. But primary key, even if you just define something as a primary key, by default, it will reject any null values if you're trying to save the null values in it. And then some basic SQL queries. So we will, sorry again, there's a lot of things to cover. We weren't able to cover everything again. But right now, maybe we'll give a few minutes for the questions. Do you guys have any questions? Anything that you want to see? Just like Hannah asked, how the application learning plan. Those are actually really good questions. And every time as a user, those questions stay in the mind. When I started working in the programming, that's the exact same question that used to hit me, like how that stores in database, like how it is flowing from one end to another. So definitely, if you guys have some questions like that, feel free to ask. At this moment, anyone have any questions? So in day 2, there is a README file containing some notes and the details, and also there are SQL queries. So this SQL queries, we went through a few of the SQL queries. In next session, we will go through all of them. Like we went into how to create tables, the drop, use if exists. This is always best practice to do that. This is kind of a graceful fail. It's like jumping from the aeroplane without parachute. So you need to have parachute when you're jumping from the aeroplane. And that goes same with the designing web application databases and mobile apps. There should be a graceful handling of error and exception. The inserting, we briefly went through it. We'll also go into the insertion, creating indexes independently and other stuff in the next session. Any questions so far? Anyone, any questions? Okay, maybe now we can end this meeting.